All right, part of section 2.5 is just basically graphing rational functions like you've done before already this year. So I'm just going to go over one of the basic ones, and then you have a couple more things to learn about slant asymptotes. So we never really went into detail about those. So if I was going to go to graph this problem here, first of all, I should have put f of x equals or y equals on here, but you can imagine this says y equals on here, sorry. So I got to factor everything, x plus 2, x minus 2 for the top. The bottom, I have 3x and x. I need 2 on the back, so I think I'm going to put 2 on the back and 1 here. That makes 6x and 1x. So if my 6x is negative, and there's a positive. All right, so I can see some cancellation going on. So we never really talked, or I never really made you figure out where the holes were. So you can see that these two things cancel. So there's a hole at x equals 2. So you have to basically go and plug 2 back into the problem. So after this is reduced, this problem becomes x plus 2 over 3x plus 1. So if you want the true location of the hole, you basically plug 2 into here, and that will give you the location of the y value of where the problem would have been had there not been a hole there. So 2 plus 2 on top is 4. On bottom, 3 times 2 is 6. 6 plus 1 is 7. So the hole is at the location of 2 and then 4/7 for the y value. So if you wanted to, you go to 2 and then 4/7. You draw a little hole right there, and that's where it's going to be. All right. So let's do our asymptotes. So vertical asymptote. There's a vertical asymptote still at -1/3 because of this guy right here. Let's see, horizontal asymptote. You can tell that now, or you can tell it from the beginning. The vertical asymptote, or the horizontal asymptote, is also, or is just 1/3. Y equals 1/3. So that was a little bit gross, but we'll take care of it. So y equals 1/3. Let's see. 1/3 is smaller than 4/7, so I'm going to put it underneath that hole that I drew. So it's going to go under that. I'm going to scooch that hole up a little bit there. All right, and then x equals -1/3. So over here, -1/3. Okay, and to find the x-intercept and y-intercept, if you want the x-intercept, you let the y value be 0. If you want the y-intercept, you let the x value be 0. So if I let the x value be 0, either in this problem or this guy right here, I get 2/1, which is 2. So 0, 2. Okay, and then for the y value being 0. So if I go up here, if I set this equal to 0, that's when the top is 0. So x plus 2 equaling 0, that would be x equaling -2. So -2, 0. All right, so then it's time to go to your calculator and go ahead and type that in. Now you always want to type in the very original problem. All right, sorry, I thought I pressed pause there. Anyway, so there we go, and graph it. So you should see kind of building itself around the areas where we were. And if you go to +2, if you go to the table, you will see that it has an error. So, it doesn't exist there. So you could probably tell what it was going to do, but it's coming around there to the hole there, and here, and here, there. All right, so there you go. That was the stuff that you already knew how to do. All right, so on to the new thing. So the new thing is this. So I always said when the top had a higher degree than the bottom, then you had a slant asymptote. So I'm going to show you how to find that slant asymptote. The way that you do that is with long division. So if you notice the top has a higher degree than the bottom, then you take x minus 1, let's see, and divide it into there. So 3x squared minus 2x plus 5. So there's still an asymptote at 1, so there's still a vertical asymptote at x equals 1, but there's also a slant asymptote. There's not a horizontal asymptote here, it's a slanted one. So x to x 3x squared, so I'd have to put a 3x right here. So then I multiply 3x times x, I get 3x squared, and 3x times negative 1, get negative 3x. Draw a line, subtract. So negative 2x, basically plus 3x here, because these go away, gets me x, and then bring down my plus 5. So to get x to look like x, I just multiply by 1, so then do that. So 1 times that, I get x minus 1. Subtract, these go away, 5 minus negative 1 is 6. So this remainder is 6. So I'm not interested in the remainder. What I'm interested in here is this answer right there. So that is going to be the equation of my slant asymptote. It's y equals 3x plus 1. So that's a line. So you notice that the top, the numerator, has a degree of 2. The denominator has a degree of 1. So that's a difference of 1. So you're going to get a linear difference. You're going to get a linear asymptote, a linear slant asymptote. If the top has a degree that's 2 higher than the denominator, then you'll get a parabolic asymptote. And so that's going to be a bit much, but anyway, 3x plus 1. So I'm going to start at 1, go up 3 over 1. Let me see, go down 3, back 1. So this dotted line right here, this is my asymptote. I also have an asymptote at x equals 1. So right here. So you're going to see what's going to happen here. You will get a graph in 2 of these 4 parts. There is a piece here, 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 and here. Those 4 sections that those 2 lines have created. The graph will appear in basically usually like 2 opposite parts of those. So we're going to go to the calculator to see that. So before I go to the calculator, let's do some intercepts and everything. So if I let x be 0 in this problem, I get 5 over 1 over negative 1. So 0 is negative 5. So we can go ahead and mark that. 0 is negative 5. If I want to let's see. Oh goodness, I've made quite a mess of it right here. Let's see. If I want to let y be 0 to try and get the x-intercept. So I might not have one because in this case, to make this equal 0, the top would have to be 0. So 3x squared minus 2x plus 5 would have to equal 0. So I'm just going to check that out real quick because I don't know if it factors, but let's do the discriminant. The discriminant is b squared, so negative 2 if I square it, 4 minus 4 times a, which is 3, and c, which is 5. All right, so you notice this 4 times 3 times 5 is too big for the 4. This is going to be negative, and that's all I need to know. So basically the top will never be 0 because it's going to be an imaginary solution, and that's all I need to know. This does not have an x-intercept. You'll see on the picture anyway. I kind of knew that was coming because basically if you get a graph down here, like we're going to get a graph going like this and like that, then most likely the graph is up here as well. All right, so let's take a look. All right, it's a little bit hard to see the one up top, but if I change my window, let's see if I can see a little bit higher and make my y max like maybe be like 19. I would have said 20, but I already started typing the 19. So there's that bottom part, and there's that top part. So I want you to notice here that what's happening is, wait a minute, that's not what I want. Oh yeah, copy here. I want Control V. There we go. All right, so what's happening here is that the graph, here is this x equals 1, or yeah, 1 asymptote, and the graph is going towards this other asymptote right here. So it's going towards the 1 when it's close to there, and then it's going towards the other slant asymptote. Okay, so it kind of follows along it like a little curb. All right, and the last one that we're going to do right here. So let's see if we can factor this up a little bit. I got 2x to the third over x squared. Whoops, I'm just going to factor. I think the bottom I can do 4 and 3. So x plus 4 and x minus 3. So I am going to have a slant asymptote, but I also have 2 other asymptotes. I have an asymptote at negative 4 and also one at 3. Negative 4 and then one at 3. All right, so something has to happen on the left, the middle, and the right, like in between all those little sections there. So this just might be a little more complicated than you're used to. So you see I'm going to have a slant asymptote. I got to put x squared plus x minus 12, divide that into 2x to the third. Well, everything else is missing, so I have plus 0x squared plus 0x plus 0. All right, to make x squared look like 2x to the third, I would need a 2x. Then multiply, I get 2x to the third plus 2x squared minus 24x. Subtract. Please go away. I get negative 2x squared. Bring down, let's see, plus 24x plus 0. So again, I would need a negative 2x to make that, or just a negative 2, sorry. So then multiply, I get negative 2x squared. So kind of I can stop here. I know this is going to be my asymptote, but I'll just finish it off. Minus 2x, and then that would be plus 24. So when I subtract, that's gone. I get 26x minus 24. So that's my remainder, but again, my asymptote is already known to me. So 2x minus 2. So my slant asymptote is y equals 2x minus 2. My vertical asymptotes are x equals negative 4 and x equals 3. And I have no horizontal because I have a slant asymptote. So 2x minus 2. So here's minus 2 up 2 over 1. So that's good enough. All right. Now remember the slant asymptote is just what your function approaches as you go off to infinity or negative infinity. So let me pause and I'll graph. All right, so I have that in there. Now, as I was saying, as you go to positive or negative infinity, your function's going to approach the slant asymptote, just like it does for the horizontal asymptote. But realize that, what was I saying? Oh, you can cross a horizontal asymptote, and so you can cross a slant asymptote also. It's just what the function is doing at the end of the graph. It's not what's happening in the middle. So it's okay to cross a horizontal asymptote, but never a vertical. So when I graph this, I only get my middle section. So I can go ahead and kind of copy that middle section over. It looks like it's like kind of like almost like a reverse cubic function. So I'm going to draw that in there. You know, it's going towards here, kind of coming across and going like that. But going down and up. But I can't see what was happening on the other sides. So I'm going to have to zoom out a little bit. I'll just do zoom and number 3 and press enter. And so you can see there are those other parts right there. So, basically they all look pretty similar. Like this comes around here, goes towards that one, This scoops around in there towards the slant and towards the vertical. Right, so that's it. So you have these 3 problems to do. And you also have to finish the couple problems from section 2.4 if you did not finish those in class today. I'll see ya. Bye-bye.